Hello everybody. Today I can evaluate logarithms by determining what exponent I'm raising the base to. So this is kind of an introduction to logarithms, what they are, and this right here is a logarithm. So here's what I'm supposed to do with this. First of all, this is called the base of the log. It's a little subscript, it's a little number, a little bit lower than everything else, and it's called the base. And logarithms are based on exponents. In fact, logarithms are the inverse of exponents. And I'm looking at the base here. So here's what this is asking me. This is saying, well, take this number. This number to what power gives me this number? So this is asking me this number 4 to what power gives me this power? So you tell me, 4 to what power gives me 4? Well, 4 to the first power gives me 4. And that would be my answer. To evaluate a logarithm, you're asking yourself, what exponent am I raising the base to get the value? I'm raising 4 to the first power to get 4. Number 2, the base of the log is 15. So I'm asking myself, 15 to what power is 1? So if I want to kind of write that out, I'm asking myself 15 to what power is 1? Well, anything to the 0 power is 1, so that would be my answer. Number 2, I'm always looking at the base of the log. What power am I raising 2 to get 16? 2 to what power gives me 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 is the answer. I want you to try 4 through 8 right now on your own. So please pause and try numbers 4 through 8 on your own. Now that you tried 4 through 8 on your own, let's go over them. In number 4, whoops, the wrong button there. In number 4, you're asking yourself, the base, 3 to what power is 27? 3 to the third power is 27. And again, you can ask yourself like this, 3 to what power is 27? You're looking at the base. 6 to what power is 36? 2. 4 to what power is 64? Well, 4 times 4 is 16. 16 times 4 is 64. 4 to the third power is 64. Again, I'm looking at the base. 2 to what power is 8? 3. 2 times 2 is 4, times 2 is 8, 2 to the third is 8. And finally, for number 8, again, I'm looking at the base. 5 to what power is 125? 5 to the third power is 125. 5 times 5 is 25. 25 times 5 is 125. Now, if there is no base, many of you will probably think to put 1 there, but that actually is not the case. With logs, if there's no base written, there's a 10. All right, for logarithms, if there's no base written, it's assumed to be 10. So 10 to what power is 100,000? Well, when I multiply something by 10, I add a 0. So 10 to the first power is 10, second power is 100, third power is 1,000, fourth power is 10,000, fifth power is 100,000, so it would be 5. 10 to the fifth power is 100,000. All right, now let's kick it up a notch. This is saying 7 to what power is 1 over 49? Well, we learned last week that negative exponents are fractions. So since I see a fraction, I know that I'm raising it to a negative exponent. So I know my answer is going to be negative, and then at that point, just ignore the fraction and just look at 49. 7 to what power is 49? 2. So the answer is negative 2. If you see a fraction, that just means you're raising to a negative power, so the negative deals with the fraction, and then ignore the fraction to determine what the actual number is. Try number 11 on your own. I'll give you 15 seconds to think about it. Okay, this is saying 2 to what power is 1/8? Well, since it's a fraction, I know the answer needs to be negative. And 2 to what power is 8? 3. That's it. If it's a fraction, it's going to be a negative. And again, we talked about negative exponents last week. All right, this one's a little tricky. Why don't you, if you would like, why don't you pause it and try and see if you can figure this one out? It's definitely a little tricky. Okay. So first of all, was a base of 10 in. Now, point 1, if I were to read point 1 I read as 1/10. Right? It's 1 point after the decimal, one place after the decimal, so that's the 10th spot. So if I reread it as 1/10, well, that gets a lot easier now. 10 to what power is 1 over 10? Well, since it's a fraction, it has to be negative. Since the 10 didn't change, it's just negative 1. So a couple little twists on that one. If there's no log written, you put a base of 10. And the little twist there, point 1 is 1/10. And when I reread it as a fraction, it gets a lot easier. I'm going to skip past those. You can do those later. ln. So ln we call the natural log, logarithm naturale. In most languages, the adjective comes after the noun. So that's why it's not NL for natural log, it's LN for logarithm naturale. Basically, here's what you need to know about ln. We said that log has a base of 10, ln has a base of 8. E is just a long irrational number, just like pi is a long irrational number, E is a long irrational number. And just like pi is in the calculator, pi is second caret, it's a long irrational number. E is right below it. You can see E above the division sign, and it's just a long irrational number. So it's not a variable, it's just a number. So take the base. This is saying E to what power is E? Well, 1. Again, because when I raise anything to the first power, it ends up with itself. Skip that. All right. The last two are definitely a little tricky. So we'll go through 17. I'll give you a chance to try 18, and we'll go from there. So 9 to what? This is saying 9 to what power is 27? Well, 9 to the first is 9. 9 to the second is 81. So there's a little bit of a problem there because it skips right past 27. So the only other types of exponents that we learned about are fractional exponents. And fractional exponents are radicals. So, can I take a root of 9? Yes, I can take the square root of 9. So that means that the root's going to go on the bottom. So if I take the square root of 9, I get 3. So now that I have 3, what power would I have to raise 3 to get to 27? 3. So I have to take a root of 2, and then I can raise that to the third power. So my answer is going to be 3 over 2. And by the way, this is not something that you're going to really need to do. This is just something that I want you guys to understand about logs, because moving forward, we're going to be using them. But it's not like you're going to be asked to do this on a test. Especially what we just did in this question, it's just a little bit of a challenge problem to understand how logs and exponents work. So again, this is saying 9 to what power is 27? Since there is no integer that will get me there, I had to look for a root. I can take the square root of 9. Whoops. I can take the square root of 9. When I take the square root of 9, I get 3. And then I can raise 3 to the third power to get 27. So the power is 3. That goes on top. The root is 2. That goes on bottom. And that's my answer. Why don't you use that same logic to try number 18. And again, it's really not the end of the world if you're having a hard time coming up with this, but I want you to give it a try. So why don't you pause it, try it, unpause it. If you're lost, then don't worry about pausing it. Don't worry about it. It's really not that important. This is saying 4 to what power is 32? Well, 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. So I know it's not an integer. So if it's not an integer power, then it must be a fractional power. So is there a root that I can take of 4? Yes, I can take the square root of 4. So the root is going to be 2. The square root of 2 is 2. So now 2 to what power is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5. That's my answer. Now, I feel like this would be a good opportunity, now that we learned how to evaluate logs, this is a good opportunity for me to show you how we can also do this in the calculator. And again, you're not going to be asked like on a test to do what we just did, but it's important for you to have an understanding of what logs are. So if I wanted to do this question in the calculator, to type log with a base in, I hit alpha, window, option 5, log base. The base is 4. After that comes 32, and I get my answer. This gave it to me as a decimal instead of a fraction, but obviously it's equivalent. Let's try, doesn't matter, let's try one that we didn't do. Let's try this one. No, let's not try this one. Let's try this one. Alpha window 5. The base is 2. 1/8 alpha y equals enter 1 over 8, and I get -3. So you can go back through all of them and you can type it in. So to type in log base, if you ever need to evaluate, this is what you would do. Now there's a regular log button without base. Now you could use the log base button, but if you're going to use the log base button, if it doesn't say log, you'd have to put the 10 in. But the log button is on the left-hand side. And then I can just type in 100,000 and get my answer. ln is right below the log button. So before it did ln of e. E is second division sign. And that gave me 1. So you can use a calculator for this, but the reason for we're doing this lesson, it's a very short lesson, is just so you have an understanding of what logs are, how they work, and really doing this by hand is the only way to truly get that. Logs are based on exponents. You're asking yourself, the base to what power gives me the number after it. That's how you evaluate logs, and that's what hopefully you got out of this lesson. Your classwork/homework is to finish this. And again, this is just a quick little short lesson that leads into logs. Have a great day.